Okay, Algebra 1, Chapter 3, Test Review. It says, which number is a solution to the inequality? The inequality says that b must be greater than 3.1, and the answer choice that's greater than 3.1 is C. Number 2, m is greater than 7 over 5. Well, that answer choice is B. Number 3 says, write an inequality for the graph. And the graph is selected between 3 and 4, so that means 3.5 is the number, and we can use n for the variable. And they have shaded the area where n is smaller than or equal to 3.5. Now I put equal to because they colored in that circle. Number 4 says Tina can type at least 55 words per minute. Write and graph an inequality to model this situation. She can type at least 55 words per minute. So she could type 55 or 56 or 57. That would be T is greater than or equal to 55. And that graph, here's 55, there's 54, there's 56. It would be a circle there that's colored in and then shading to the right. Number 5 says solve and graph your solution, and number 5 says x minus 1 is less than or equal to negative 11. So we're going to add 1 to both sides. It's going to be x is less than or equal to negative 10. On that number line, I'm going to have negative 10, negative 9, negative 11. It's a circle that's colored in. And if we test these out, is negative 10 less than or equal to negative 11 less than or equal to negative 10, or is negative 9 less than or equal to negative 10? Now, since we're on the negative side of 0, our relationships are backwards from what we learned when we were in elementary school, and negative 11 is smaller than negative 10. Number 6 says x minus 7 is greater than negative 3.1, and we start this one by adding 7 to both sides. So x is greater than 3.9. So on my number line, I'm going to have 3.9. On this side I would have 4. On this side I would have probably 3.8. Open circle, and I want x's that are greater than 3.9, so I'm going to shade to the right. Number 7 says w plus 4 is less than or equal to 4. So I'm going to subtract 4 from both sides. So w is less than or equal to 0. There's 0, 1, negative 1. It's a colored in circle and shading to the left. Number 8 says x over 5 is greater than 4. You're going to solve this inequality by multiplying both sides by 5. X is greater than 20. It's an open circle and shading to the right. That's problem number 8. Problem number 9 says x over 2, and it's got a negative out front, is less than or equal to 1. Now when that happens, you have the option of putting the negative with the x or with the 2. It's going to be a lot easier on you if you'll put it with the 2. So let's treat this as x over negative 2 is less than or equal to 1. Then we need to multiply both sides by negative 2. Those will cancel. And when you multiply or divide by a negative, you must flip the direction of the inequality. Don't forget that part of the rule. So x is greater than or equal to negative 2. And there's negative 2, negative 1, negative 3, a colored in circle. And since x needs to be greater than, I'll shade where the negative 1 is. Number 10 says 5x is greater than or equal to 20. Divide by 5. X is greater than or equal to 4. So it's a colored in circle. And is 3 greater than or equal to 4, or is 5 greater than or equal to 4? And 5 is the one that's true. So we're going to shade on that side. 11. 11 is a compound inequality. It says negative 6 is less than or equal to 2x minus 4 is less than 8. You're going to work this one twice. You're going to cover that part up. You're going to have negative 6 is less than or equal to 2x minus 4. Then you're going to cover this part up, and you're going to have 2x minus 4 is less than 8. Then you're going to need to solve each one of these independently. So we're going to add 4 to each side. So negative 2 is less than or equal to 2x. Divide by 2. Now I'm dividing by regular 2. I do not change the direction. The number I'm dividing by is positive, so I do not change the direction. Negative 1 is less than or equal to x. That's a negative 1. I'm going to solve this side. I'm going to add 4. 2x is less than 12. Divide by 2. X is less than 6. So on the number line, I'm going to need to have 6 and negative 1. Well, over here at negative 1, there's negative 2, and there's 0, there's 5, and there's 7. At negative 1, I need a colored in dot because it has an underscore. And the x's here need to be greater than. So if I plug in, if I do my little testing, is negative 1 less than or equal to negative 2, or is negative 1 less than or equal to 0? And this is the side that makes it true. And you really should shade all the way across, but we know something's going to go on over here, so we're going to hang on just a second. Now over here at 6, it's an open circle, and we want this one, is 5 less than 6 or is 7 less than 6? Well, 5 is less than 6, so we're going to shade here, all the way that direction. Well, the parts that overlap would be the solution, and there's going to overlap here in the middle. So that is the solution for number 11. Number 12 says solve the inequality. Negative 5x minus 7 is less than 28. So you're going to add 7 to both sides. You're going to have negative 5x is less than 35. Divide by negative 5. Ding, ding, ding. There's your indicator right there. Turn that direction around. X is greater than negative 7. Number 13 says 3 times b minus 8 is greater than 15. You're going to start by doing the distributive property. It's where you multiply here. 3b minus 24 is greater than 15. You're going to add 24 to both sides. 3b is greater than 39. And then we will divide by 3. b is greater than 13. 14. 6 plus 12p is greater than or equal to 6 times p plus 6. So we'll distribute. So 6 plus 12p is greater than or equal to 6p plus 36. Subtract 6p from both sides. So I get 6 plus 6p, those cancel, greater than or equal to 36. Subtract 6, 6p greater than or equal to 30. Divide by 6, p is greater than or equal to 5. And that is question 14's answer. Number 15 says 13h minus 13 less than or equal to 24h plus 9. So we need to start by subtracting 13h. That cancels. I get negative 13 is less than or equal to 11h plus 9. I'm going to subtract 9. It's going to be negative 22 is less than or equal to 11h. Now I'll need to divide by 11. I'm not dividing by negative, I'm dividing by regular 11, so I don't change anything, and I get negative 2 is less than or equal to h. Now, when you go to look for this answer on multiple choice tests, they may have it written this way. So I want you to know that that and that mean the same thing, because look, h is on the big side of the mouth, h is on the big side of the mouth, so they can write it two different ways. Number 16 says, suppose you had $D in your bank account and you spent 19 but have at least 59 left. How much money did you have initially? Write and solve an inequality for this. So number 16 says you had this much money in your bank account. You spent 19, but you have at least 59 right now. So the money you have is either 59 or greater. If it's at least 59, that means it's 59, 60, 61, something like that. So it's greater than or equal to 59. Now they want you to solve for D. So you've got to add 19 to both sides. So D is greater than or equal to 78. So you started out with $78 or more. So the answer for this one would be D minus 19 is greater than or equal to 59, and then they're going to have a semicolon, and they're going to say D is greater than or equal to 78. 17, your class hopes to collect at least 350 cans of food for the annual food drive. There were 122 cans donated the first week and 132 the second week. Here, I'm going to put this on here so you can see it. The first week, this many. The second week, this many. Write an inequality that describes this situation. Let C represent the number of cans that must be collected for the third week for you to meet your goal. So you want that and that and that to be at least 350, which means 122 plus 132 plus the cans for the third week need to be at least bigger than 350 or equal to 350. So there's my inequality. And then they ask me to solve it. How many cans would that take? So I'm going to simplify. Now I'm going to put these together. They need to be combined. That is 254 plus C greater than or equal to 350. Then I'll subtract 254 from both sides. C is greater than or equal to 96. Number 18 says, the French Club is sponsoring a bake sale. Their goal is to raise at least $135. How many pastries must they sell at $3 each in order to meet that goal? So every pastry that they sell, I'm going to write 18 right over here, they're going to get $3. $3 for every pastry. And they want that to be greater than or equal to, not 350, that was the number from the last problem, $135. So to solve, you just divide by 3. P is greater than or equal to 45 pastries. They need to sell at least 45 pastries. Number 19 says all real numbers that are greater than negative 8 but less than 8. They want you to write a compound inequality. So they also want you to graph it. I think it'd be easier to graph it first. We've got negative 8 and we've got 8. All real numbers that are greater than negative 8. So it can't be negative 8. Got to be bigger than negative 8. So it's on this side, all that direction. But less than 8. Can't be 8. Got to be less than 8. So that's my graph. So I want my X or my N to be greater than 8. N is, I got that going the wrong way. Negative 8 is less than n is less than 8. That's the best way to do that. You want that in the middle. Number 20, write a compound inequality that this graph could represent. Well, we want all the x's that are less than -2. That's this part of the graph right here. And actually the word would be or. All the x's that are greater than or equal to 3. And that is that part right there. 21, all real numbers n that are less than -7 or greater than 9. Write an inequality. N that are less than -7 or n is greater than 9. 22, solve the equation. If there's no solution, write no solution. So here's 22. 6 times the absolute value of n minus 11 is 37. You want to isolate that absolute value, so you're going to do that just like we've always done. Divide by 6. You're going to get absolute value of n is equal to 8. So what could n be? Well, n could be 8 or -8. 23, what number would you add to each side in order to solve? There's a picture of 23. You would add 9.7. 24, suppose that you start with at least $52 in your savings account and you deposit $27 each week. Write an inequality to describe how much money you have after W weeks. If you do this for 11 weeks, will you have enough to buy a bicycle that costs $340 to show your work? Okay. So here we go. We start out, the money in my bank account is greater than or equal to $52. And I'm going to add to it $27 each week. There's my equation. Write an inequality to describe. That's what we did. If you do this for 11 weeks, okay, we're going to do this for 11 weeks. So it's 52 plus 27 times 11. So 27 times 11 is 297 plus 52. It gives me $349. So the money would be greater than or equal to $349. So would you have enough money to buy the bicycle for $340? Yes, you would have enough money to buy the bicycle. 25 says explain why this has no solution. Well, I'm going to try to solve it. I'm going to try to see what happens here. I want to add 3 to both sides. So this is going to be 2 times the absolute value of x equals 6. I'm going to divide by 2. Absolute value of x equals 3. So this does have a solution. The solutions are 3 and -3. This is not a good question. I'll tell you what I'm going to do. I'm going to mark it out and I'm just going to give you one free question. How about that? So if you've watched this video and you've written down how to work all these problems and you get to number 25, you'll know it's the free question. Don't tell your friends. You'll get some bonus points. Have a good day.